Hello everyone, you are all welcome to lecture number 1263 and today's topic is resonance effect on the reactivity of the molecules as a reactant. So I have already discussed the two effects and these effects are the we can say delocalization or the movement of electron along the bond or towards most electronegative or withdrawing of the electron. So this electronic displacement along the carbon-carbon bond is playing very important role, and here when I am going to discuss the resonance effect here, the benzene ring is involved and where the pi electrons they are delocalized, and when I say pi electron delocalized means pi electrons can move from 1 carbon to 6 carbon, and in this way they are called delocalized, and in this delocalization some centers of benzene ring, maybe some ortho, para or meta directing groups. It depends upon the type of attacking reagent. For example, if it is electrophile, which is deficient in electron like NO2, nitration of benzene is called electrophilic substitution. So it is called meta directing group. When we are taking nucleophile, for example, OH minus. OH minus means it is nucleophile, and once it is attacking to benzene ring or resonance hybrid, it is called ortho-para directing group. Means in the benzene ring at ortho and para, the activity of electron will be there and the attacking species will be directed to ortho and para grouping. So here let me show you, if it is like benzene ring, so benzene ring what we are showing, it is showing just like that 3 double bonds are there, but it is not like that. This one you can represent like this, and here it can be represented by like this, or it can be represented by here. So this is all in resonance form, and these pi electrons actually finally we can give that it is in the form of delocalization, and that is moving like this. Pi electrons are completely delocalized, and this delocalization is taking place like this: 1, 2, 3, 4, 5 and 6. 1, 2, 3, 4, 5 and 6. Double bond, single bond, double bond, single bond and double bond. So here in this carbon there is alternate double and single bond. Alternate double and single bond is called conjugated system. It is called conjugated system. Conjugated system. And in this system, conjugated system means it will provide electronic load in this way, like this. From carbon 5 to carbon 6. So here this electron, carbon 1 to carbon 6, electron can move from carbon 1 to carbon 6. It is called electronic road, and this electron is having that free movement, that is delocalization. This condition is necessary. So here I have given two examples, and in these two examples it is shown that how the polarity is developed in these two A and B cases. In one case, the electron-rich chlorine is linked to aromatic ring, that is benzene ring, and how the electron shift and movement is there, and how the positive and negative, these charges are delocalized. And the second case is where electron-rich hydroxy group is linked to benzene ring, and how these positive and negative charges are delocalized, and this delocalization of charges play very important role in the reactivity of these molecules. So here number one, if single and double bonds are present alternatively, such condition I have already told you is called conjugation. Conjugation means alternate double single bond, and that alternate double single bond is responsible of providing that I call it electronic road for electron to move freely without any porthole, just like your motor road where you are going with your car. If there are portholes or there are some big hurdle, you cannot move. The same way, unless there is electronic road, electron cannot move in the benzene ring from carbon 1 to carbon 6 or even in open chain unless there is conjugation. Conjugated system. Then the pi electrons. Yesterday I have already told you about pi bond, pi orbital, pi electron in detail. Electrons are having electronic road to move from carbon 1 to carbon 6. This is called delocalization. The movement of electron, pi electrons from one carbon to other carbon or 6 carbon is called delocalization of pi electron, and this delocalization is responsible of making the molecule a resonance hybrid. That is called a resonance, and it results in the polarity of this system. And once such type of resonance is there, it will result in the polarity of the molecule. For example, in a simple case I have given you, that is butene, where there are 4 carbon atoms and there are 2 double bonds, but these 2 double bonds are double, single and double. So it means from here pi electron is delocalized here, and from here it has chance to shift to other last terminal carbon, and in this way the electronic road is there, and with this shifting of the electron always a resonance is shown by double arrow, both side arrow is there. It is CS2, it has donated the electron, it will carry positive charge and the one which has accepted the electron will carry negative charge. In this way, this conjugated system, because of movement of the electron around the carbon and that movement of pi electron, will cause the polarity of the molecule, and this polarity of the molecule means it is going to affect its reactivity. The second example, and here same thing also happens when an atom or group with a lone pair of electrons is situated in conjugation system with a compound double bond and single bond. For example, case number A, if chlorine is linked to this benzene ring where it is alternate double and single bond, and then electron shift will take place, and this minus plus, these two ions will be developed, and how the minus negative charge is delocalized around the ring, and that delocalization of negative charge is going to contribute in the reactivity of the molecule. The second condition is again here, hydroxy group is attached to benzene ring. The same shifting of the electron will take place, and minus charge will be delocalized from one center to other and other to third one. So in this way, the charges are moving around the ring, and that is going to affect the reactivity of the molecule, and also it determines the resonance energy and stability of the molecule. So this conjugated system resonance is playing important role in determining the reactivity of the molecules which are ready as a reactant. So with this I will stop, and all the students must be knowing once they are in chemistry undergraduate or postgraduate classes that there are some conditions for any molecule to show resonance and to show delocalization. The first is that there should be pi electron. Second, these pi electrons must be delocalized. Third, there must be conjugation, means alternate double and single bond. And in this reaction, the steric factor is also playing role, because sometimes if your molecule is having lot of bulky group attached, like methoxy group, like hydroxy group, like methyl group, and they are very close, then there will be some instability, and that is called steric hindrance in the reaction of the molecule. So with this I will stop. Thank you very much for watching the lecture.